there, Jessica. Welcome.
Welcome, Jessica. Okay. Hello, everyone.
Hi, Valerie. It's nice to see you guys. Welcome to today's class. We hope you guys are very excited.
Hi, Valerie. How was school today? What did you do in maths? What topic are you dealing with in class at the moment?
Hey, Lumka, welcome.
Oh, you did a maths test on statistics. Interesting. Did you have some of the stuff we've been dealing with in your test? Did you do like measures of central tendency or any of that stuff that we've been talking about lately? I'm interested to know. Also, you can jump on, if you turn your mic on, sometimes it's just quicker to chat. Looks a bit like a crime scene. Maybe I shouldn't use red.
While we wait.
I'm still enjoying the novelty of drawing on the screen digitally. It still amuses me. At some point, it'll run out. I'm still drawing pictures. Okay. So how are we doing on time here? Well, we're still quite early. So everyone, I was just saying before we started how it feels like so long since I've been online with you guys, and it hasn't been that long, but I'm sure you're a bit rusty. So today's do now is based on stuff we were doing before. And so there's the main first question. There's a box and whisker where it asks, how would you describe the skewness? But there are also some extra questions down here that I made up that would be good for us just to remember what were we doing the last time we were together. Okay, so I want you to do that while we carry on welcoming people. Oh, Valerie, almost all we have covered so far was in the test. And so did you know, that's great. I'm always happy when we're in line with what students are doing in class. Because I know sometimes people are a little bit out of sync and stuff like that. Awesome. Let's see what else.
Can everyone see the screen? I'm wondering, Peter, if we can maybe just zoom in a bit, unless you have some more drawing.
We can zoom in, absolutely. How's that?
Yes, that looks great.
That's the other magic about being online. Like in the classroom, if you draw too small, it's like, it's going to take a while to get this bigger. Whereas in the world of Zoom, it's just a pinch in the zoom. Okay, I'm about ready to go. Anything more from you all? All good. Okay, let's begin. Okay, everyone. So in the previous lesson, we were talking about data for a while, and we were talking about how do we represent data with pictures or graphs. And so today's do now is a picture called a box and whisker plot that represents a set of data, but it summarizes that data. And so in the last lesson, we also spoke about, look, what if we want to give a word to describe the shape of the graph? And if I remember correctly, I drew some little like histograms, little bar charty things like this. And I said, look, if we have something that looks like this, we might give it a certain type of word. to describe it. And so that's what the first question is asking about. And if you know how you would describe it, please put it in the chat. And then the next part of the question is find Q1 for this data set, find Q2, find Q3, and so on. And I'm hoping that you will know how to read that off the data set. So let's just call that A, B, and C. So I want you to put in the chat, how would you describe the skewness of the data? And then what are your answers for A, B, and C? I want to see if you can read that off. And then we'll go from there. So the box in the box and whisker is over here. And what you should for Q1 is going to be 810. What is Q2 and Q3 going to be? And what do those things mean? So if we look here, halfway through the data, Q2, that is going to be 940. And Q3, if you get split cutted here, Q3 is going to be 1,100. Now, these are almost like the fences that divide up the data. And so what we know is that with this fence, there's 25% of the data to the right of it and 75% of the data to the left of it. And that's kind of what the quartiles are doing. They're dividing the data up into quarters. So these are the main ways we have. And also, the other thing to remember is that the data is written from smallest to biggest. It's grouped in ascending order. Now, the IQR is going to be Q3 minus Q1. So in this case, we're going to do that. And we get 290. And so that is going to be this range. And we say the middle 50% of the data is sitting there. Now, when we compare different data sets, it may be that the middle 50% of the data is very close together or it's far apart. And the IQR or the interquartile range will help us in knowing that. Okay. Then the third one is called, I asked you here, how big would a number need to be an outlier for this data set? Now, in the previous lesson, we spoke about what an outlier is. Can you put in the chat for me what you think an outlier is, or jump on with a word? Or maybe someone turn their mic on. Like, what is an outlier in statistics? Because this idea will come up again and again. So you can give me a word, I can hear your voice. I'll just give you a moment to think about that. What is an outlier in statistics? Oh, welcome. I see lots of familiar faces or familiar names and faces. Vuyo, Boitumelo, Oretiwe, Asamakle, Sinosipo. Oh, it's wonderful to see all you guys back. So what do you think an outlier is? Any ideas? If I said to you 1,350 is another value, for this data set, how would I know if that would be an outlier for this data set? What criteria do we have? If we think back to the last lesson, we can even go back and have a quick look. So in the last lesson, when we finished, I'm just going to jump to the end. We had this thing here. And we had something called the 1.5 times IQR rule for identifying outliers. What is the 1.5 IQR thing got to do with stuff? Let me jump back to today's lesson. The magic of technology. Any ideas? Okay, so the basic idea is that we take whatever the IQR is. In this case, the IQR was 290, and we times it by 1.5. So I'm going to get a value. So 290 times 1.5, and I get 435. Now, if I go to the third quartile and I go the distance of 1.5 times the interquartile range, I'll get the upper boundary for my outlier. And if I go from Q1 down by 435, then I'll get the lower boundary for an outlier. So basically, for something to be an outlier, it would have to be above 1,100 plus 435, which I guess would be 1,535. So any value greater than that would be an outlier. And I just wanted to come back to this because we ended the last lesson with this, and this idea of an outlier is fairly important. And then obviously it can work in that direction there. Okay, now the last question, let's go here, is could you draw, actually, no, I'm still answering about the skewness, and then I'll do the last question. How would you describe the skewness of this data? Well, basically, if you look at this data set, the first 50% is quite close together, whereas the second 50% is quite far apart, which means that essentially this graph has a bit of a tail going to the right, or we say that it's positively skewed. So the data on this side, in the top 50%, is more spread out, and it has this sort of tail effect. We spoke about it in the previous lesson, where it looks a bit like it's got a tail running off. And so we would say the data is skewed to the right or positively skewed. Okay, so that's the answer for that one. And then the last one is, can you draw an approximate histogram from the data set? Now, a histogram is a way of showing grouped data. And I didn't show you a way of drawing a histogram from a box and whisker, but we're going to approximate it by doing the following thing. What is the range on which our data here is sitting? The smallest value is 750, and the biggest value is 1250. So in some ways, I could actually divide my data up into counts of 50. So let's say like 800, and then 850, 900, 950, 1000. How am I doing? Okay, I'm going to run out of space here. Maybe I should go in hundreds. Actually, let's do hundreds. So 700, 800, 900, 1000, 1100, 1200. So let's say these are the intervals. If you look at this data set, there's a lot more data sitting in the up from sort of, well, 50% of the data is sitting between 750 and 950. So we might say something like, and the next bit is more spread out. And so my histogram is going to have this, it's only approximate, I know I'm not doing it perfectly, but it's going to have this sort of shape over here. Okay, I think I've probably done enough do now, so I'm going to move on, but I hope that that was helpful for just kind of reminding you of the last lesson. So I thought I would just say, look, in the previous lesson, this is what we did. We did grouping data in frequency tables. We spoke about box and whiskers and histograms. We talked about the shapes of distributions, and we talked about outliers. So that's what we did in the previous lesson. And if you missed it, you can go back and watch the video. And then for today's lesson, a preview of where we're going, we're going to talk about, let me zoom in. We're going to talk about other ways of drawing graphs of data. So a histogram is not the only way of drawing a graph of group data. There's another thing called a frequency polygon, and there's another thing called a cumulative frequency graph, or an ogive. So those are the two things we're going to spend some time on. And then in the second part of the lesson, we're going to talk about an introduction to probability, which is quantifying uncertainty, basically. Now, before I move on, I would like a thumbs up or thumbs down vote. If you have heard of a frequency polygon or a cumulative frequency graph, if you've heard of those two things, give me a thumbs up. And if you haven't heard of them, give me a thumbs down. And that will just be helpful in helping me kind of seeing how fast I need to go. Okay, it's about half and half. Let's get those votes coming in, just so I can get a sense of what we're dealing with. I saw a couple of thumbs, and I don't know, Alzan, if you're seeing the majority there. I'm seeing about 3/4 say yes, a quarter say no. Is about what I'm seeing. All right. Okay, so basically, these are two different types of graphs, and they're actually very closely related to a histogram. They're just a slight adaptation. And so we're going to build on the previous stuff by doing this. Okay, so what is a frequency polygon? So a frequency polygon is often you build it from a histogram. And the reason we have it instead of a histogram is that it's very hard to put two histograms on top of each other. But if you have a frequency polygon, which I'll show you now, you might have one frequency polygon that looks like that. And then you may have another one that looks like that. It's much easier to compare data sets when you draw them as frequency polygons. So that's one of the main reasons. Now, the way we draw a frequency polygon, the one way of doing it is if we have a histogram, and a histogram is basically like bars that are close together. If we want to draw a frequency polygon from a histogram, we just find the middle of each interval. And what we need to do is we add an interval on the lowest side, but basically below our lowest interval, we add another interval. And we also add another interval above the highest interval. And we find the middle of that interval. And all we then do is we connect those points with straight lines. And you'll remember a polygon is just a shape that has straight lines that is closed. So that's why we have to have these extra bits at the end to close the polygon. And so really drawing a frequency polygon is just like taking a histogram, adding two extra intervals, and then always joining the middle. Now, in practice, what we often do is we actually draw up a set of coordinate pairs and we say, look, what is halfway between this interval? So maybe this is between, say, 10 and 20. Then we'd say halfway is 15. And then we would say, what point is that in line with? It's in line with 7. And so then we'd use the point 15,7 as a point on our frequency polygon. And that's what I'm going to show you now. But really, it's all a frequency polygon is. It's just a histogram where you find the middle of each interval, add two extra intervals on the beginning and end, and connect them up. Okay, so let's learn how to do this. So this is a completed frequency polygon. And what you'll notice is that at the end, the bits are actually at 0. And that's because those are the two extra bits that were added on. But the histogram that it came from is going to look, say, something like that. Let's have a look. So I actually should be in line with these points. Sorry. Let me do that again. So all I'm trying to show you here is that this is how the frequency polygon kind of came to be and how it's connected to the histogram. Okay, I should actually be right on the ground with that one. So whenever you think of a histogram and a frequency polygon, know that they're very closely related. So the instructions are calculate the midpoint of each interval and then plot the ordered pair. Plot the midpoint of the interval below the lowest. This sounds so wordy. I mean, all it's saying is basically find an interval above the highest point and then plot the middle at 0 and do the same for the one at the bottom and then join these points. So the words make it sound more complicated than it really is. We're just going to do it and you'll see what I mean. So let's do an example. It says 80 of the learners at Alexandria High School were surveyed to find out how many minutes each week they spent collecting waste material for recycling. So that's the story. It's about recycling. The grouped frequency table shows the results of the survey. So if we look at this, this tells us between 9 and 13, so 8 students spent between 9 and 13 minutes. 28 students spent between 13 and 17 minutes, and so on. It says here, use a frequency table to draw a histogram and to then draw a frequency polygon on the histogram. I'm not going to ask us to draw the histogram. We are going to go straight to drawing our own frequency polygon. Now, what do we need to do over here and over here to get started? And I'd love an answer from the chat box or from somebody jumping online. What are the 2 intervals that we need to add at the beginning and at the end in order for us to be able to make a frequency polygon? I kind of mentioned it above, but I'm interested to know, what would you put in here and in here? And I want to reply in the chat, or I want somebody to jump online and be brave. What interval goes over here? What in the green bit there? Cool. Any ideas? I'm going to give you some time to think about this, because this is the key idea for this whole question. Look at the size of the intervals here. How big are these intervals? What's the difference between 9 and 13, 13 and 17? What do I need to do in order to find the middle of it as well? Any ideas, everyone? Even if you just give me a word. I almost heard that. What was that?
Will it be 5?
You are on the right track. How did you get 5?
There's a difference of 4 between all the data sets.
Perfect. Exactly that. So you get the lowest value you're going to go to is going to be 5. And the interval is basically going to be from 5 to 9. Well, let me actually just get rid of this. 5 to 9. And what's going to be at the top here? How would I carry on if the interval was, it seemed like there was a group of 4 each time. So wouldn't it just be between 33 and 37?
Yes.
Perfect. Okay, now, the other thing we need to do is we also need to give it a count. Now, because these are made-up categories, there's going to be a 0 and a 0 here. But we're not actually done yet. We need to find the midpoint of these intervals. And I'm a little bit messy here, but what is going to be the midpoint between, let me zoom in. What is going to be the midpoint between 5 and 9? Any ideas? It's going to be 7, right? And then the midpoint is going to be 11. And then the midpoint is going to be 15. Then the midpoint is going to be 19, 21. No, not 21. It is going to be 20. Let's have a look here. Halfway between 21 and 25 is 23, 27, and then 31. Okay, now we're almost ready to draw this graph. We're just going to do the last part, and then I'll do a neat version of it. I'll bring up the answers. So the points that you're going to plot, your coordinate pairs, are going to be the following. You know you need to be halfway between 5 and 9, which is 7 and 0. And then you're going to have 11, 8. And then you're going to have 15, 28. Okay, and I'm actually going to put the correct answers up because it's getting a little bit too messy, but I'm just wanting you to see how I'm making this table. So to draw a frequency polygon, all you need to do is add an extra column for the midpoints and then an extra column for the actual points you're going to plot on your graph. And so because I have the answer here, I'm going to bring it up for you. Let me just get my fancy things to move around. So the table itself should look like that. And then the final one. So that's what I was trying to show you up there. And so these points over here are going to be the points that we use to make our frequency polygon. And so we go and we simply plot those points. So 7, 0 may be over here, 11, 8 might be up here, 15, 28 would be up here. And we're simply going to join these points to give us our final answer. And so that would be, the final thing should look like that. And so even though it looks quite tricky, in reality, all we've done, if I'm summarizing it again, is I've added an interval for the end and the beginning. I found where the middle is for each of these things, and then I'm just connecting them. And the main reason we have this type of graph is just because it's easier to compare things if we're dealing with frequency polygons. Okay, give me a thumbs up if you feel like you've got the basic idea of frequency polygons. Give me a thumbs down if you feel like you need more practice. Let's see those thumbs. Okay, so obviously what you need to do is you need to go and practice these things, but I just wanted to make sure you got a clear idea there. Okay, I'm seeing mostly thumbs up. You can give me thumbs down. I won't take it personally, don't worry. So I just want to get a feel for what is going on with everyone. Okay, then the second graph. Okay, I'm going to move on. Okay, so I see some thumbs down there. So what we'll do is in the next lesson, I will do a little bit of a revision on this thing, on this particular one as well. Okay, the second graph for today is called a ogive or cumulative frequency curve. And I think you can guess that there's going to be, I've been referring to cumulative frequencies for a while now. And so there's going to be a chart with a cumulative frequency. And so basically what a cumulative frequency curve does is it shows the information in a cumulative frequency table. And it's really, really helpful for estimating things, especially estimating Q2 or the median, and also for estimating the interquartile range for grouped data. One important thing that we need to bear in mind, and I'll illustrate this now, is when we make an ogive, the cumulative frequencies are plotted at the upper limit of the interval. Now that sounds like a weird word, but basically in the previous question, when I was plotting my points, I was plotting the middle of the interval. So in the previous one, we always went to the middle. In this graph, we're going to add an interval at the beginning and at the end. But what's going to be different is that when we have our intervals, we're not going to go to the middle of those intervals now. What's going to happen is the point that we choose is going to be at the end of the interval. And so just watch out for that because there's a slight difference on that. So the main difference is it's got cumulative frequency. Or in fact, let me go back for a second. We're illustrating grouped data. In these grouped data, we have different types of graphs we can make. Some of the graphs have different rules for drawing them. In this particular case, we know that we are going to have a beginning and end extra interval, and that when we plot the points, they're going to go to the end of the interval. The other thing that's different is that in this curve, it's going to be a smooth shape, not a sharp line shape. So that's the other thing to bear in mind. Okay. So I want you to take a moment and using what you know about frequency tables, I want you to add an interval at the end and at the beginning. And I want you to try and fill out these spaces using whatever logic you've used in previous questions. And I'll do the first one for you, okay? In fact, the first two, and then you can fill out the rest. The cumulative frequency at this stage is 4. If this interval goes from 0 to 10, and I'm using the end point as my item, the ordered pair is going to be 10, 4. And in fact, I'll do this one with you too. Since this is going up in tens and this gets to 0, this is going to have to be from -10 to 0. At this stage, the frequency would be 0. That would be 0. And this point would be 0, 0. I know that's a bit weird here, but you'll see what I mean in a moment. It's like an artificial one. This next one is going to be 16 because 12 plus 4 is 16. I'm going to the end of my interval now, so it's 20. And what value is it going to be? It's not going to be 4 or 12. It's going to be 16 because this graph focuses on the cumulative frequency. Okay, I want you guys to fill out the remaining 5 levels, and then I'm going to ask you some questions, but I want to give you some time to do that because I feel like I've been talking a bit much and you guys can probably would enjoy the practice. So I'm going to give you 2 minutes to do that, get some water, and then I'm going to ask you some questions. Give me a thumbs up if you know what you do, if you know what to do. Give me a thumbs down if you're like, listen, funny man on the internet, I don't know what's going on. Okay, I see a thumbs up. Thumbs up if you know what to do, thumbs down if you're feeling clueless. We're trying to fill out the remaining missing information in this table, this frequency chart. Okay, what would this next one be? So we have to be careful we don't make silly mistakes here. 28 plus 16. It's going to be 44. And then that is going to be 30, 44. There's a bit of a pattern to this. Then 32 plus 44. Let's make this a bit smaller, 76. And then 40, 76. And then, in fact, I've actually got the correct answer here below. So it's probably neater than what I've done. But this last interval is just going to be from 60 up to 70. And I need that as we go. Or do I actually need it? Sorry, I actually don't. Sorry, I don't need that. In this one, I don't need the end one. I just need the beginning. Okay, so let me bring up the correct answer for everyone to see. Okay, now this these arrows make it seem very, very confusing. That's part of the reason why I didn't want to show you all the stuff at the beginning. And in some ways, I feel like the words are overkill. So what is important and what's different? So you'll see that I added in that extra category at the beginning. So I do need to add in the extra category at the beginning. I don't actually need to add in the category at the end. So in that sense, it's because my last point is at the end of the last interval. So we don't need anything extra. How do I get my cumulative frequencies? I'm adding each time from the frequency column, and then I've got these points here. And so now to draw my cumulative frequency curve, all I'm going to do is I'm going to plot these points. So you've got 0, 0, then 10, 4 might be here, 20, 16 would be here, 30, 44. Now, again, I'm doing this very kind of freehand. I'll show you a neat one now. Like that. And then like that. And then like that. So it's often they talk about the ogive being an S shape. It's a little bit like an S shape. And so it's going to look like that with my data points along the way. Now, the important bit is what is actually on the axes. So on this axis is going to be the cumulative frequency, and that makes sense because we use the cumulative frequency from our graph. And over here are just going to be the intervals for the data. In fact, my intervals should match the data points, shouldn't they? So the intervals should be opening and closing in line with the dots over here. Okay, and that's all a cumulative frequency curve is. I'll show you a neater one because I think it will cause less confusion, but that's how I would go about drawing it in person. So let's have a look at this. That one over there. Okay, now, all I want to do with you is now work out how to use this graph, how to estimate things. So this is the famous cumulative frequency curve, or ogive. What if I asked you, where is the median on this graph? Okay, so where is the median on this graph? Would anybody know how to start that? How would we begin estimating from this graph what the median is? You'll remember in the previous questions, there's nothing about where the median is. Any ideas? Would anybody like to jump on and give us an idea about how to do this? Okay. What did we normally do when we try to find the median in previous data sets? What was the first thing I always went to? I used like a little formula. Can you remember what that was? Can you remember something with n plus 1? What was that thing with n plus 1 that I used? Put the formula in the chat if you can remember it. Ah, I see it, Valerie. I see it. I think you're onto something here. So what Valerie wrote in the chat, in case you can't see it, is 2/4 times n plus 1. You could have also, sorry, this isn't Q2, this is the position of Q2. You could have also used 1/2 times n plus 1, or you could have used 50/100 times n plus 1. This is the formula that gives us the position of Q2. But then the question is, okay, well, what do I use for n if I'm going to use that formula? So let's do it like we did it before. Position of Q2, 1/2 times n plus 1. But what is n? Any ideas what n is from this graph? Where would we look? If we go back to the table, maybe the original table can tell us that we were looking at. What is the original table? Well, if we add up all the items, it's going to add up to 120, because that's the cumulative frequency. And if we look at the graph, apologies for this wonky screen. If we look at the graph, all you need to do is look, what is the highest value that I get to? This is the cumulative frequency of all the students involved. So all we're going to do is we're going to say 1/2, 120 plus 1. And so the position of the median is just 60.5. Okay, 60.5. Now, the problem is I don't want its position. I want the actual value of Q2. And this is where the ogive is clever. It says, go to the position 60.5 and draw a straight line across and see where you get to. That is the position in this data set of the median. Well, now, in order to get the value of my Q2, it's going to be approximately 35 minutes. And so for this particular data set, the median for the data set, and the question was about the time it takes to travel to school, it's going to take approximately 35 minutes in terms of the question. Okay, now, using that logic, using this idea, could you please work out an estimated value for Q1 for me? And can you work out an estimated value for Q3 using this ogive? And I'm going to give you 2 minutes to do that, because if you can do this, then I think you've understood the main idea of how we can use an ogive to estimate. So use the logic that I used for the median, and then I want you to type into the chat what you think Q1 is and what you think Q3 is. And in fact, I'll even start you off. You're going to have to find the position of Q1 and the position of Q3 in order to do this. So do those calculations first, and then once you've done those, tell me what Q1 is and tell me what Q3 is. Okay, over to you, my people. I see some estimates coming in. I like it. I like it. Keep it coming. I'm even using my calculator here just in case I make a silly mistake. 30. Okay, so that's the position of that one. And that is the position of this one. Now, these are not the values. These are just the positions. Okay, let's have a look at what's coming in so far. I see one estimate so far. It's around 45.5. That's an estimate so far. I don't know what the answer is, but I want to give you guys some time to lock in your estimates. What do you think the estimated value of Q1 or Q3 is for this particular question? I see a few more coming through. Fantastic. Okay, so for Q1, the position is 30.25. Okay, if the numbers are written from smallest to biggest, we'd count 30 items in. Now, because the data is grouped, we actually can't deal with individual items. That's why this estimate is so helpful, because it deals with grouped data. Just in case you're wondering, like, why are we suddenly dealing with group data as opposed to individual? So let's go to approximately 30.25, and I go across to my data set. Now, again, it's approximately here. If I go down, it looks to me like Q1 is around 25, approximately, around 25, 26, somewhere around there. If I want to find Q3, or the third quartile, that one will be around 90.75. So maybe it's a little bit, again, we're just estimating at this stage. I'm not even, it looks to me like it's a little bit before 40, so 44 about, give or take 45, somewhere around there, 44, 45. And so that would be Q3. Okay, and so that is basically how we can learn to estimate what the value of the quartiles are when we have group data. and we can use the OGIVE to do this. Now, again, you do want to practice this, but the process is actually not that bad. So let's have a look at the, okay, I've done that already. Okay, now here's one sneaky question, because I know you guys, like, you may have forgotten what a percentile is. What if, in fact, I'm going to do it with you because I believe in you guys. I know we can do this. What if I asked you to give me an estimate for the 80th percentile? Now, I haven't spoken about percentiles since I think the first or second lesson. What would P80 be for this particular data set? And ask yourself, okay, if I want to find the position of P80, what do I do? And then ask yourself, what would P80 be based on that? And just to remind you what the 80th percentile is. The 80th percentile is 80% of the way through the data. The third quartile is actually the 75th percentile because it's 3/4 of the way through the data. So I just want to see, could you give me an estimate for the 80th percentile if I was using this graph? And then we're going to move on. Okay, so because of time, I'm gonna jump in here and I'm gonna say, you know what? All you need to do is you take 80 over 100 and then you use the same formula as before where it's n plus 1. So we say 121 times 80 over 100 or 0.8 and we get 96.8. 96.8 is the position of the 80th percentile, not its value. So we go to about 96.8. And the value is going to be about 47, 48 or so. And so what that is saying is that 20% of students took longer than that to travel to school, and 80% of students took less than that. But that's still a bit of a higher, that's still a bit of a, takes a while to get used to that idea. But I just wanted to throw that in because I could see that you were absorbing this. Okay, now that is it for graphs of grouped data. And we're going to call that part of the syllabus to a close. And I'm going to take a moment just to let us kind of ask any questions. Are there any areas, before I move on to an introduction to probability, what things would you like to still revise a bit more? So if I do a revision session later, I think on the last lesson, and I come back to stuff, what areas from the first 4 lessons would you like me to comment a bit more on? And this might also just be from stuff you've done in class at your own school.
Sir?
Yes, hi.
I came a bit late for the session starting from the beginning, right? So I wanted to know if you guys have already done the estimating of the lower and the upper quantities.
Yes. Okay. So we did that. Are you talking about estimating the lower quartile and the upper quartile?
Yes, sir.
Okay. So in video number 1, because these videos are on YouTube already, we dealt with finding the lower quartile and the upper quartile exactly when given individual data items. And then we moved on to today, we were dealing with something called grouped data. And today we're learning how to estimate those, but we're using the formulas that we learned in lesson 1. Does that help?
A little bit, because we started the estimating data on school, right? So
okay. Do you know about the Watobe website? If you go, they're labeled, and if you go, you can watch that. You can watch that video, but I will review that again in the last lesson in the series. Does that make sense? But in the interim, I would say have a look at that video.
Okay, so thanks.
But thank you for the question. Are there any other questions like that? It's so helpful for me as the teacher to know what areas you guys need a bit more help in, or something you just want me to go over with another example. Okay, we'll have another chance at the end of the lesson. But all I'm going to do is to end today, I'm going to give an introduction to the new topic, which is probability. And we're going to do one question like this, and then we're going to play a fun quiz. And that's going to be it for today, because I've already squeezed in quite a lot. So I want you to think about this question over here. Actually, okay, yeah, let's do this. So on the probability line below, it says, show where you think the probability of each of these events should be placed. The first has been done for you. So A has been placed over here on this line. And I want you to think, where would you place B, C, and D? Where would you place them on this line? The probability scale is from 0 to 1, or sometimes it's spoken about being from 0% to 100%. And often this chapter is tested together. So we're still dealing with data, but we're applying the theory of probability. And I will give you a whole introduction in the next lesson to probability. But for now, I just want to see what you remember from previous grades. Where would you put B? Where would you put C? Where would you put D? So what's the probability of getting ahead when tossing a fair coin? Where would we put B? Would we put it here, here, and so on? Obtaining a 1 or a 2 when throwing a fair dice. Now the word or is important there. Obtaining a red ball when choosing 1 at random from a bag containing 4 red and 6 blue. So I just want you to commit, and I'll give you the answers in a moment. So an important idea in probability is always how many possible outcomes are there, and then how many outcomes are favorable when you consider the question. So obtaining a head when tossing a fair coin, a coin only has 2 possible outcomes, and getting a head is one of them. And so we say the probability of tossing a head is going to be 1 out of 2, or it's going to be 0.5 or 50%. And so B would have to be over here. Now for C, it says we're throwing a dice. How many different outcomes are there on a dice? There's 6. But the problem in this question is we could throw either a 1 or a 2. And so 2 of the possible options are favorable for us in the question. And so the probability of getting a 1 or a 2 is going to be 2 out of 6, or 1 out of 3, or 33%, or 0.3 recurring. Those are all the same thing. And so we would say, where would 0.3 be? I suppose if that's 10, 20, 30, C would need to be there. And then for D, it says we have a ball, and we have 10 balls in this bag, and it says there are 10 possible ones. There are 4 red and 6 blue, and we want to know what is the probability of getting red. So it's 4 out of 10, or 0.4, or 40%. And so this is going to be D over here. Okay, and so this is just a little reminder about probability and the idea of probability scale. In this section, you often deal with coins, you deal with cards, you deal with balls and hats. What are some of the other things they like to? Anything which is uncertain that we can quantify, we often will study with probability. Okay, so to end today, I have made a little quiz that I know we're running short on time, but I'd love for us to try and do this all together. And we're not actually going to go to this thing. We're going to go to... Can everybody see the screen? Classic. Oh, wait, hold on. Let me launch this on another browser. Can you guys all see like the fun game screen?
Yes, we can.
You see, okay.
Yes,
Okay, now let me see if I can actually do this. I've never done this before. You are going to be the first class to do this with me live, but we're going to try and do this live all together. And then continue. Okay, and nope, this is not going to work. Join my quiz. Oh, it can't. Okay. Can you guys all go? Can you all go to joinmyquiz.com and type in the letters 888442? And I want to see if your name pops up on the screen. I see a name. Valerie, welcome. I'm going to wait for just a minute more. So you type in joinmyquiz.com and then you type 888442. Aha, welcome, Zimi. Give you a minute more. So if you're on a computer, you can always create another tab for this, or whatever it may be. I just want to see if you guys can get into this. Ah, there we go. It is working. Fantastic. Elzon, we might run a little bit late today. Are you going over to another lesson? Or are you okay for...
No, we can go on.
Okay, just checking. Because I'd like to see if we can do this properly.
Yes,
now that
of
everyone... Welcome. Hey, now I feel like I have a proper class here. I can see everyone. They're joining the quizzes. It's awesome. Okay, now we're going to start the quiz now. But even if you haven't got in yet, just remember the number 888442. Because you can still join this even when we start. But we're going to end today with this fun quiz. And so let's start. And let the games begin. Now, this is the beginning, so don't stress if you're getting it wrong. I just want you to try your best. That's all. Alzan, does the sound come through a bit loud on your side or not? Or can you control the volume? Because I'm aware it's quite loud sometimes.
I can control the volume, but it's not that loud on my side.
Well done, guys. This is going well. Well done, everyone. I can see things are going well. Just do the best you can for now. Don't. So I think my power has gone out. Alzana, are you still there?
I'm still here.
Okay.
Here I am.
Sorry, everyone. I think that something's gone wrong with my power. I'm going to bring this to a close, but it's been a good experiment. But thank you so much. ESCOM has struck. But luckily I've got backup. Tumelo is the but yeah, just before we finish the day off, if you could just give me just a quick thing of how was that? Did you enjoy it? Something like that. And then we'll close off.
Yeah, guys,
and thank you for your patience, Alzan.
No problem. We've got Limka who said it was very fun. Thanks,
Okay,
Limka.
that's good.
Valerie said it was great.
Okay, cool. Awesome. Yeah, I've always found my students enjoy a bit of sort of consolidation like that. And I just hadn't done it live because there's many moving parts, but I think we can make it work.
Yes.
Okay.
So more comments is Tumelo that just said, yay. So Roselo said it was awesome. Jessica gave a thumbs up.
Fantastic.
Zodlo Guanana. Am I saying that right? Zodlongwana. It was fun. I enjoyed my first lesson even though I was late. That's awesome. And Sine Sipu also said it was fun.
Okay. We'll definitely try and make it happen more often now that I know that it can be good for us. And yeah, well done. I'm going to hand over to you, Alzan. Thank you so much. And we'll continue with probability in the next lesson.
Great. Thank you so much, Peter, for your time and for all your effort and energy. And also thanks to all the learners for participating, for giving it your best. Yeah, we know that this isn't easy being online and not being in class, but we really appreciate when you ask questions and we enjoy answering you. So keep it up. And then well done for completing 5 lessons already. There's only 3 left. And I think, Peter, you just said we'll continue with probability next week as well.
Yeah, so probability and we'll start Venn diagrams as well in the next lesson. Yeah.
Awesome. Awesome. So you know what to expect next time. Before that, we'd love for you to do the Watobe lesson to just get some practice in. So you go onto the Watobe app for those who don't know yet, and you search for probability. And as you go into probability, you'll find basic probability. Peter, am I correct if I say it's this one?
Yes. Yeah.
Okay, awesome. And then this is the lesson that you guys need to complete before Thursday, before we see each other again.
Yeah. It'll just build on the stuff we did in the quiz now, and that quiz at the end of the lesson. It's just the basics of the language of probability, and then we'll work with that. Yeah.
Awesome. Okay, guys, that's all from our side. Thank you so much for joining, and take care of yourselves. We'll see you again on Thursday.
Cool. Cheers, everyone.
Bye.
Bye. Pleasure. Bye.